Welcome everyone to video lesson number 2, where we're going to review some basic math skills, starting with rounding numbers. Now when you're rounding numbers, you're going to cut the number off at the desired decimal place with a vertical line. You're going to look to the right of the line. If the number is 4 or less, that number will stay the same to the left of the line. Okay, that's called rounding down. If the number is 5 or more, you're going to add one more to the number left of the line. That's called rounding up. Okay? Everything to the right of the line, you're going to drop. So all the digits right of the line get thrown away, and everything left to the number that you rounded will stay the same. So let's see some examples. So first up, it says round this number 100.2351 to 2 decimal places. So I find where the second decimal place is. I'm going to cut my number off right there. Then I look to the right of the line. Looks like that's a 5. So that's 5 or more. I add one more to the 3. So this becomes 100.24. Notice how all the numbers right of the line get dropped, and everything left of this number that I rounded stays the same. Okay? Another example, round this number to the whole number. So 42.246 to the whole number. Now whole number, that's the ones place. So we're going to draw our vertical line right there, cutting off our number. And then we look to the right of the line. In this case, we have a 2. 2 is less than 5, right? So that means my number left of the line will stay the same. So this number would round to 42 for rounding it to the whole number. Now we also want to get really comfortable using our calculators. So go ahead and pull out your calculator. We're going to do a couple calculations on our calculator. I'm going to pull up mine here. I get rid of this. And my calculator should be right here. So go ahead and type it in. It says 14.03, so I type that in. And I'm going to times that by 54.2. Okay? So sometimes it comes out on our calculator and I say 2, in this case I said 1 decimal place. Sometimes people just will take that number, the 4, and that's it. Okay? But you really need to do the same thing. In this case you would have been okay, but you need to draw that line in there, okay? And then look to the right. To the right of the line, it's a 2. So in this case, yes, that 4 will stay the same. So the number would be 760.4. Okay, that's rounding numbers, a quick review. Okay, our next topic is scientific notation. Now, scientific notation is used by scientists to represent really large or very small numbers, which we'll often be dealing with in chemistry. Now, the nice thing about this system, not only is it a shorthand, it's based off the power of 10. Okay, so what we'll see is it's always 2 numbers multiplied together, some coefficient times 10 raised to some power. Okay, so for example, if I have the number, a large number like 25,400,000, I would write that in scientific notation as the product of 2 numbers. Okay, so there's the coefficient 2.54 times 10, and then the exponent in this case would be 7. All right. Now, what that really means is 2.54 times 10 times 10 times 10, 7 times. Okay? So a couple things to note about scientific notation. When we write something in scientific notation, there's only going to be 1 digit before the decimal. So always 1 digit before the decimal. The number of digits in our notation indicates the accuracy, and we got into a little bit of that with our measurement. Scientists take that very seriously. But just for our class, we're going to keep 3 digits. And so in scientific notation, I always want you to have 2 decimal points. That'll just make it a little bit easier. Okay? Now, the power of 10, okay, indicates the number of decimal places to move, right? Because if you times the number by 10, you're moving the decimal 1 to the right. If you divide by 10, you're moving the decimal 1 to the left. So how that's going to be indicated is if we have a positive exponent, we're going to move to the right, however many decimal places that the exponent is. When you have a positive exponent, you have a number greater than 1. If we have a negative exponent, that means we have a number less than 1, okay? And so whatever that number is, you move the decimal the corresponding places to the left. Okay, let's see some examples. A couple of quick notes before we do those examples. Note that commas and decimals are different. We'll get into that when I do some examples, but be careful of that. And then on your calculator, which I want you to use for scientific notation too. The key to make a power of 10, scientific notation on your calculator, if you have a scientific calculator or an app on your phone, will be the capital E, or the capital EXP. Okay, so some examples. So the first example, 5.62 times 10 to the 8th. Okay, so again, this number is in scientific notation, but what number really is that? Well, what I would do is I would move my decimal 8 places to the right, because it's a positive exponent. This should be a number greater than 1. Okay, now you can do that by doing this thing where you go like that. I prefer to think of zeros as a decimal place or a placeholder, because that's really what they are. So in my mind, when I do this, since I know I'm going to the right, I'm going to write 562. So that's 2 decimal places I moved, right, to get there, 1, 2. But then I got 6 more. So I can do that really quick by just adding zeros. Okay, so I add 1, 2, 3, 4, 5, 6 zeros. Okay, and that's my number. Now I'm going to go back and put the commas in and group these, every 3. So 1, 2, 3, 1, 2, 3. So that number is 562 million. Okay, so that's in standard form. Notice the next example, I have a negative exponent. So as soon as you see a negative exponent, you know that number is less than 1, because you're going to move the decimal that many places to the left. So again, we could do this thing where we go 1, 2, 3 and put the decimal, and then you put the zeros in like that. I like to, you can do that. I can like to just mentally move it. So I know I've got 42, right? So I went 1 here, and then I just add 2 zeros, and that makes it just a little bit cleaner. So that would be 0.0042 in regular notation. Okay, now what I want to do is I want to write numbers in scientific notation. So I have this big old number right here, 8,250,000,000. Let's write it in scientific notation. Now remember, I have to have a number between 1 and 10 times 10 raised to some power. So we're going to make this now 8.25. I like just to keep 2 decimals. Remember, you have 3 numbers, times 10. And again, this is a number obviously larger than 1, so the exponent should be positive. So what I'll do is I'll just put my decimal here mentally and just think, okay, I went 3, 6, 9 places to the right. Remember, the right-hand turn, positive exponent. So 8.25 times 10 to the 9th. In our next example, example 4, we have a number less than 1. If it's less than 1, I should be thinking in my head, that's a negative exponent. So let's put together our scientific notation. A number between 1 and 10, that decimal point has to go between the 7 and the 8. So 7.86. And again, I'm cutting it off right there because I think 4 is less than 5, so that number stays the same. I round down, times 10 raised to some power. Now you know that it's going to be a negative because it's less than 1. I'll just mentally again put my decimal here and then think about 1, 2, 3 to the left. So again, it's negative 3. So 7.86 times 10 to the negative 3. Go ahead and grab your calculator. We want to do a couple calculations using scientific notation. So I'll pull up mine while you pull up yours. This is where sometimes we get in trouble because our calculator throws out all these numbers and we don't know what to do with it. So 65,000,016, make sure you type it in carefully. Your calculator is only as good as the numbers that you type in, times 240.52. Okay? So there's my number, big honking, that's scary. I'm going to ask you to put that in scientific notation. Okay? So you should be thinking, okay, I can do this. I need a number between 1 and 10, or just 1 digit in front of the decimal. So my digit has to go, or my decimal has to go right there. Okay? So this is going to be 1.5, and we can do some work right here. The 3, that would round this down to keep it the same as a 6. So we would have 1.56. So let's write that down. Times 10 raised to some power. Now, was it more than 1? Obviously, this is more than 1. So we're going to have a positive exponent. And if my decimal point is here, so that's really 3, 6, 9. That's 10 places. So what we'll do is put 10 right there. Okay, so positive 10. 1.56 times 10 to the 10th. Okay, a couple more calculations for you. Pull back our calculator. Let's get rid of this stuff. Sorry, I have to do this with a smart board. But we'll clear out our calculator. Now just get used to typing in the numbers and using this scientific notation key that you have on your calculator. It's very useful. So 3.0, and notice it says times 10 to the fifth. So instead of hitting times 10 and figuring out the exponents and parentheses and all that, all you got to do is find this double E's or the EXP key. For me, it's right here. So I hit that, and then it gives me E to something or a capital E. That's the scientific, that means times 10, that E. So, so we're going to times that by the power of 5. And then I'm going to multiply that times 1.0. Again, I find that key, exponent key, times 10 to the negative 2. Okay? My answer is 3,000. Okay? So get used to typing that in. That'll be useful. Now, some of you guys are recognizing that if you have the same base, right, you can just add the exponents. And certainly you could do that. This would just be, if you're thinking that way, this would just be 3, right, times, so 3 times 1 is 3, and then times 10 to the fifth times 10 to the second. Really, you can just add those exponents together. So you get times 10 to the third power, and 3 times 10 to the third power. If you move the decimal 3 to the right, you add 3, 0, you get 3,000, which is what you got on your calculator. So sometimes you can do it mentally as well. Okay, just one more real quick. Let's do the next one. So 6.7 times 10, so we're going to, again, use that exponent key, get practice finding and using that, times 10 to the 8th, divided by 1 times 10 to the second would equal that number right there. So what is that? 6,700,000. Okay? And again, you could do the same thing in terms of with your math skills. If you have these skills, 6.7 divided by 1, of course, would be 6.7. And then when you divide by powers of the same base, again, you just subtract the exponents. So 6.7 times 10, 8 minus 2 is 6, and that is the equivalent to what we just got. Okay, last but not least, we're going to talk about writing decimals as percents. Now this is pretty easy if you were tracking with what we were doing before. Basic rule here is we're going to multiply the number by 100 and then add a percent sign. So if you were tracking, multiplying by a power of 10, we move the decimal to the right. Since it's 100, we're just going to move the decimal 2 places to the right and then tack on the percent sign. So our first example, 72.1, let's move the decimal 2 places to the right. So this would just turn into 72.1%. Done. Easy. Okay, this is going to come in very handy in the lab because we do a lot of percent work in terms of our yields and percent error. Last example, if we wanted to write it to the first decimal place, again, we'd have to first move the decimal, so you got 34.5282, okay? And then we could follow our rules of rounding here. So the first decimal place, I would cut it off right there. Again, I would round down here, so my answer would be 34.5, and then tack on the percent sign. Okay, so I'm hoping that that was a helpful review. Go ahead and complete the worksheet, and then I'll see you in class next time.